So in this paper, I'm interested in a particular argument, a particular objection that's been made against the Dutch book argument for probabilism. So first of all, what's probabilism? Secondly, what's the Dutch book argument for it? Thirdly, what's the objection? And then fourthly, how might we respond to that? And I'm going to try to give three different possible responses to the objection. So probabilism is this. It's a norm that governs your credences. So what are credences? They're your degrees of confidence in different propositions. So they're a sort of graded version of belief, sometimes known as partial beliefs. So for instance, if I say something like, oh, it's 20% likely that that horse will win, or I'm 60% confident that it's sunny outside, then what I'm doing in those situations typically is reporting my credences, reporting my partial beliefs or my degrees of confidence, my strengths of belief. So those are my credences. And of course, I've got credences in a range of different propositions. In this part of Bayesian epistemology, we typically assume, though it's not in fact necessary for anything that happens, that the set of propositions that we assign these credences to forms an algebra. So it's closed under the Boolean operations, and it has the top and bottom elements. And really throughout, well, let's just think about these propositions that you assign credences to as sets of possible worlds. Of course, people can argue for a long time about what exactly the objects of belief are, but it's not going to be relevant to this particular objection that we're thinking about here. So your credences are assigned to these different propositions, and what your credences are measured on is a scale from 0% to 100%. 0% is minimal credence, 100% is maximal credence, or equivalently the scale from 0 to 1. So 0 is minimal credence, 1 is maximal credence. And so we represent U, who has these credences over all these different propositions in this kind of algebra of propositions, which we think of as sets of possible worlds. We represent U by your credence function. And that's just a function that takes each of the propositions that you assign credences to. It's going to be sunny tomorrow, this horse is going to win the race, and so on. It takes each of those propositions and it just returns your credence in them. So it's really just a way of sort of notational device, really, for talking about the credences that you assign. And what probabilism does is it imposes certain reasonably strong but also quite lenient constraints on that credence function. So the first constraint, P1a there on the slide, is the requirement that you assign maximal credence, that is 1, to the necessary proposition, sometimes called top, which is notated by that sort of T shape. So you assign maximal credence to that, so that's the set of all possible worlds. Similarly, you assign minimal credence, 0, to the contradictory or necessarily false proposition. So that's P1b there. And then secondly, if you've got two propositions that are mutually exclusive, so in our possible worlds terminology, two propositions where there's no possible world they share in common, no possible world that makes both of them true. If you've got two propositions like that, then your credence in their disjunction, which of course is their union in the possible worlds framework, your credence in their disjunction is the sum of your credences in the two disjuncts. So that's probabilism. So that's the norm of probabilism. And now we're going to look at what the Dutch book argument is for that norm, and then we'll look at this objection to it. So the Dutch book argument is, in a way, the central argument for probabilism. It's the one that's certainly the one that's been around for longest, and it's the one that probably most has been written about. It originates in the 30s in the work of Frank Ramsey and Bruno De Finetti. Gets sort of refined in the 50s by people like Shimony, and then it gets sort of discussed a lot in the 70s and 80s, perhaps less so in the 90s, but there's really large literature discussing the kind of pros and cons of different bits of the argument, even quite a lot of literature discussing how you even formulate the argument. Okay, so that's the sort of origins of the Dutch book argument. What does it say? Well, the way I'm going to present it, it's got three claims. It makes three claims. First one I'm calling Ramsey's thesis. It's not particularly standard terminology, but there aren't really standard terminology. There isn't really standard terminology for these for these premises. Ramsey's thesis is just a thesis about what bets your credences require you to accept, or in particular, what prices your credences require you to pay for particular bets. And then we have the Dutch book theorem, which tells you that if your credences violate probabilism, then there's a certain sort of bet, certain sort of series of bets called Dutch books, which your credences do require you to accept. And the third premise says, look, if your credences require you to accept books of this sort, the sets of bets of this sort, books of bets of this sort, if your credences require you to accept them, then they're irrational, and that gets you probabilism. So let's look at it in a little bit more detail. First of all, Ramsey's thesis. So quite often throughout, we're going to be talking about an S pound or an S dollar bet on X. So S is just some amount, some real number. It can be positive, negative, or it can be zero. And we sometimes call this the stake of the bet, sort of the amount of money that's at play in the bet. And a bet on X with stake, S pounds, pays out S pounds if X is true and 0 pounds if X is false. So very straightforward. And what Ramsey's thesis tells you is how much you should be prepared to pay, how much you're required, in fact, to pay for bets like that. So suppose your credence in this proposition is P, so that's some number between 0 and 1, remember, or it could be 0 or 1. Then consider an S bet on X. Then if X is less than PS, then you're rationally required to pay that amount for the bet. If it's equal to PS, you're rationally permitted to pay that amount and rationally permitted to refuse. And if it's greater than PS, then you're rationally required to refuse to pay that. So you're rationally required to refuse that bet. So how might, so that's one way of stating it. Here's a way of motivating that. So it basically says this, sort of got 3 parts. First of all, says, look, if you have minimal credence in a proposition, then there's no positive amount that you should even be permitted to pay for a bet on that proposition with a positive payout. So you should, let's take a pound bet. There should be, if I have 0 credence in the proposition that bet is concerning, then there's no positive amount I should pay for a £1 bet on the proposition. Similarly, if my credence is maximal, then I should be required to pay anything less than £1 for that bet, that £1 bet on the proposition. And I should be permitted to pay £1, because paying £1 for me is, and so those are the first two claims. So if I have minimal credence, then there's no positive amount I should even be permitted to pay for a positive bet on that, for a £1 bet on that, let's say. If my credence is maximal, then I should be required to pay anything amount less than £1, any amount less than £1 for that bet, and £1, I should be permitted to pay £1 for it. And then finally, the amount that I should be required to pay, the amount that I should be required to pay, kind of the maximum amount, or the bound on the amount that I should be required or permitted to pay to enter into a bet on a particular proposition, should increase linearly with my credence. So as my credence goes up, so should that amount go up in proportion to that. And that's just essentially what Ramsey's thesis says. So it's got quite a sort of strong intuitive motivation, I think. Dutch book theorem then talks about particular sorts of set of bets. So we can think not just about individual bets, but sets of bets, that is kind of, a number of different ones. So take a set of bets, we're going to call them a Dutch book, because you talk about books of bets. There's no real consensus on why they're called Dutch books, but a set of bets is a Dutch book if, when they're taken together, they'll lose you money at all worlds. So that is the amount that you would be paying for them, the total amount you would be paying to enter into all of them, would exceed the total amount that they would pay out at any particular world. Okay, so you'd be guaranteed to be paying out more than you would be getting back. They could pay out different amounts to different worlds, and of course bets typically will. But in this situation, what you know about the Dutch book is that it will pay out more. It will pay out less than you will have ended up paying to enter into it. And we're going to say that your credences are incoherent if, via Ramsey's thesis, they require you to accept each of the bets in the Dutch book. Okay, so if there's some Dutch book and Ramsey's thesis says your credences require you to accept each of the bets in it. And what the Dutch book theorem tells us is, look, if your credences violate probabilism, remember those three clauses, if your credences violate one of those clauses, then they're going to be incoherent. That is, if your credences violate probabilism, then there's going to be some Dutch book of bets that, when all taken together, are going to lose you money for sure. There's some Dutch book that your credences, such that your credences will require you to accept each of the bets within that Dutch book. So that's the Dutch book theorem. And then finally, there is this other thing called the converse Dutch book theorem. Some people think you need to put that into the argument as well as the Dutch book theorem. I'm not going to get into issues about that because I don't think it's relevant to what's going on here. Final premise says something about the relationship between your credences and what they require of you and the rationality of those credences. So your credences, if your credences, so we say that your credences are exploitable. We'll see why it has to have this kind of R in front of it a bit later on, because there's going to be another form of exploitability. But your credences are exploitable if there's a pair of actions or a series. So if there's a pair of actions such that the first dominates the second, but your credences rationally require you to choose the second. Or indeed, if there is a pair of series of choices such that the first one dominates the second one, that is, taken in total, the first one is better than the second one at all worlds, such that your credences require you to always choose the ones in the dominated series. So we say that one action dominates another if it's guaranteed to be better. That is, at all possible worlds, it's strictly better. So your credences are exploitable if there's a pair of actions such that the first one is always guaranteed to be better than the second one, but your credences rationally require you to choose the second. So what this third premise of the Dutch book argument says is, if your credences are exploitable, then they're irrational. Okay, so putting that together, you get probabilism. So I'm interested in a particular objection to this argument for probabilism, this Dutch book argument for probabilism. And it's one that, although I think probably articulates a vague unease that people have when they first meet the Dutch book argument, as far as I know, hasn't really been discussed until this paper by Brian Hedden from only 5 or 6 years ago, I think, which is then sort of followed up later, and I think independently, by Michał Tomasz Godziejewski, who's top right there, and Leszek Wronski, who's bottom right. So between them, these three have formulated this objection. So I'm going to talk through that. So the objection goes like this. So second premise of the Dutch book argument is a mathematical theorem. No one's going to deny that. We will end up very slightly tweaking Noûs exploitability later on, but roughly we're going to stick with it throughout. The target of this objection is Ramsey's thesis, the one that had this kind of stated this normative connection between your credences and your choices. It told you how you should choose rationally given credences that you have. And remember what Ramsey's thesis said. It basically said, look, if there's $100 bet on a particular proposition, you've got credence, say 60% in that proposition. You should be required to pay any amount up to $60 for it, and you should be permitted to pay $60, and you should not be. You should be required to refuse the bet for anything more than $60. That was Ramsey's thesis, and I think Hedden sort of puts it exactly the right way. I think when you come across this, it seems sort of strange, because we all thought that we had a theory of rational choice under uncertainty. We all thought that we knew how to make decisions using our credences. We were supposed to maximize subjective expected utility. And the way Ramsey's thesis often is stated, it's not mentioned how, if in any way, it connects to maximized subjective expected utility. As we'll see, it does connect to it, but in a rather peculiar way. So what Hedden and Gorzhevsky and Vronsky say is you shouldn't use Ramsey's thesis, or the correct account of how to make rational decisions under uncertainty is given by maximized subjective expected utility. That's what you're required to do when you're making a choice. What happens if we replace Ramsey's thesis by that, which is the correct way to make decisions using credences? Do we still get the Dutch book argument for probabilism? Do we still get an argument for probabilism? And their answer is no, we don't. So why not? So here's a way to illustrate why not. Let's take some credences. Here's a way to illustrate why Ramsey's thesis and maximized subjective expected utility clash with one another. Because you might think, oh, well, look, maybe one follows from the other, or they're at least compatible or something like that. In fact, they clash. There are going to be certain sorts of credences where they give different, make different demands. Now, it should be said that if your credences are probabilistic, that is, if they satisfy probabilism, then the two of them will always give the same demand. Maximized subjective expected utility is much more general because it doesn't just govern your betting behavior, but any sort of decision making. And we'll see that that's important in a moment. But they agree on all the cases that they both treat. But if you're non-probabilistic, if your credences violate probabilism, namely all the cases we're actually interested in the Dutch book argument, then they can sometimes give make contradictory demands. So here's an example. Suppose you're 60% sure it will rain and 90% sure it won't, and you're offered a £100 bet that it will rain. Let's look first of all at Ramsey's thesis. And let's suppose you're offered this bet for £50. Ramsey's thesis says what you do is you take the stake of the bet, £100, you multiply by how confident you are in the proposition that the bet is on, rain, so that's 60% or 0.6, you take 60% of 100, that's £60. £50 is less than that, so you're getting a bargain. You're getting something that you think is a good deal. Now, it turns out actually this does follow from maximized subjective expected utility on one particular way of understanding that, but it's not the way that Hedden thinks we should understand it. So suppose you think the following. If you have a particular credence in rain, say, and I offer you a bet on rain, then you should accept that bet. It offers me a bet for a particular price. I should pay that price. I'm required to pay that price. If and only if the expected value of that bet is positive when I use my actual credence for as the probability of rain. I don't use my actual credence in not raining for the probability of not raining, but instead just take 1 minus my credence in rain. So in this case, what I would do to calculate my expected value for this bet, £50 for a £100 bet on rain, is to do 0.6 times what the outcome would be if I were to win the bet, if it were to rain. Namely, I'd win £100, but I'd have paid £50, or I'd make £50 overall. Plus 0.4 times, and then negative 50, which is the outcome if it doesn't rain, because I won't get anything at all, but I'll have paid out £50. And the result of that is £10, so I should pay that amount. You're rationally required to pay £50 for the £100 bet on rain. But of course, maximized subjective expected utility says no. When you're doing the expected utility calculation, you shouldn't use some fantasy credence for not rain. You should just use the credence you have in rain, and not rain, sorry. So I should do the same calculation, expected utility calculation, but instead of having my probability for rain be 60%, my probability for not rain be 40%, I should use what in fact is my credence in not rain, which is 90%. So when we do that expected utility calculation, which is along the bottom, we get £15. Minus £15. So it's got lower expected value than refusing the bet, because refusing the bet just always has 0 as its expected value. So I'm rationally required to refuse to pay that amount. So Ramsey's thesis, maximize subjective expected utility, clash, Hedden, etc. think should go with maximizing subjective expected utility. But so far we don't actually know for sure whether using maximized subjective expected utility might not still get us probabilism at the end. It might not still be that whenever I have a non-probabilistic credence function, maximized subjective expected utility, in fact, leads me to accept some Dutch book. But Hedden has this really elegant example which shows that that's not going to be the case. So it's a very simple example, the one that we've got here. It's got 3 worlds, world 1, world 2, world 3, and it's got each of the subsets of those. So at the top, we've got the necessary proposition, at the bottom, the necessarily false proposition, then we've got the singleton worlds, and then we've got the doubletons. And here's the credences that you assign. So 0.9 to the necessary proposition, so already a violation of probabilism. 0.8 to the proposition which is true at world 1 and world 2. 0.8 to the proposition that's true at world 1 and world 3. 0 to the proposition of worlds which is true at world 2 and world 3. And then 0.7 in world 1 and 0 in the other 2 worlds, and 0 in the necessarily false proposition. Now it turns out, Hedden can show, there will be no series of bets on the propositions that we have in here, such that you will be required by these credences and maximized subjective expected utility to accept the bets, and yet those bets constitute a Dutch book, namely they'll lose you money for sure. So this, plus maximized subjective expected utility, looks invulnerable to a Dutch book. There's no Dutch book that these credences will accept you to enter into. A kind of neat way to see this, basically the betting behavior that this credence function is required to enter into is precisely the same betting behavior as the betting behavior that the following credence function is required to enter into. This one, where what I've done is I've just gone through each of the credences in that previous one. If it was positive, I've set it to 1. If it was 0, I've just left it as 0. Now, this one is a probabilistic credence function, and it can be shown that it will require exactly the same bets that the previous credence function required. And we know, in fact, this is from the converse Dutch book, so there is some relevance to this. We know that if you have a probabilistic credence function, you're not going to be vulnerable to a Dutch book. So this one isn't vulnerable to a Dutch book, requires the same bets as the previous one, so the previous one isn't. So that's a really neat illustration. How might we respond to this objection? So the objection roughly is, look, Ramsey's thesis hasn't been motivated, or at least nothing has been said for why we should accept Ramsey's thesis instead of our other account of how you should choose under uncertainty, namely maximize subjective expected utility. We can show that Ramsey's thesis and maximize subjective expected utility clash in the requirements they make. If you put maximize subjective expected utility instead of Ramsey's thesis, you don't get an argument for probabilism. There are going to be non-probabilistic credence functions, like the one 2 slides ago, that will not be that maximized subjective expected utility does not require to enter into any Dutch books. So how might we respond to this? Well, one way to respond is to sort of accept, sort of concede to Hedden and et al. That is to concede that maximized subjective expected utility is indeed a plausible account of how we should choose under uncertainty, but add, so is Ramsey's thesis. Because remember, before I motivated Ramsey's thesis to you, I gave this sort of account of why we might want it. If you have maximal credence, then you should be able to pay everything. You should be required to pay anything up to the total stakes of the bet to enter into the bet. If you have minimal credence 0, then you should not pay any positive amount to enter into the bet. And crucially, the amount that you should be required to pay to enter into a bet should rise linearly with your credences. So I've given it a good motivation for Ramsey's thesis, and didn't go via maximize subjective expected utility, but it seems like a good plausible justification. So if that's the case, and Ramsey's thesis and maximize subjective expected utility are incompatible or can clash in certain cases, as we've seen they are, perhaps the way to go is to say, look, both are permissible, or choosing in line with each is permissible. So that is, you replace Ramsey's thesis with the permissive Ramsey's thesis. So let's see what that says. That just says, yeah, you, instead of saying that you're rationally required to pay the certain amount if you have this credence, then you say that, look, if Ramsey's thesis tells you that you must do it, then you're permitted to do it. So if Ramsey's thesis says that it's permissible, then it's permissible, essentially. Because it's permissible to go either of two different ways. So it's permissible to follow Ramsey's thesis, or it's permissible to follow maximized subjective expected utility theory, because although they're incompatible, they are both plausible in their own ways. So you do that, you accept that, and then you accept, and then you have to slightly strengthen the no R exploitability claim, so that it becomes not no R exploitability, but no P exploitability. And what that says is your credences are P exploitable if there's some pair of actions, such that the first dominates the second, but your credences rationally permit you to choose the second. So that's what it means for credences to be P exploitable. And this new premise in the argument says, if your credences are P exploitable, then they're irrational. Okay, so what this says is you're not irrational only if your credences, it's not the case that just your credences requiring you to choose a dominated option that can render you irrational. It's also your credences permitting you to choose a dominated option or a dominated series of options. Okay, so if you put that in place of R exploitability, you have the permissive Ramsey's thesis, then basically you're going to get the argument for probabilism, because instead of the argument going, look, it's irrational to have credences that require you to be Dutch booked, and all non-probabilistic credences require you to be Dutch booked, there is some Dutch books actually, those credences require you to accept it. This says, look, it's irrational if your credences permit you to choose a dominated action. Your credences permit you to enter into a Dutch book. And by permissive Ramsey's thesis, and the Dutch book theorem, if your credences are not probabilistic, then there is some Dutch book such that by the permissive Ramsey's thesis, your credences permit you to accept each of those. So that's the kind of, in a way, the sort of, it's the smallest change that you could make to the Dutch book argument in order to allow it to avoid the expected utility objection. Okay. So next up, so that's one way that you could go, but you might not accept it. You might not think that even the permissive Ramsey's thesis is true. I think this is probably the position of Hedden. He doesn't even think that Ramsey's thesis is a permissible way to go about doing it in the situations where it clashes with maximized subjective expected utility. It's got to be maximized subjective expected utility that wins out. It's got to be that one. So what could we say in that sort of situation? Well, here we turn to a different sort of argument, pragmatic argument for bounded, for something that we're going to call bounded probabilism. So the pragmatic argument for bounded probabilism, essentially the idea is to think that, is to ask whether we can sort of resurrect an argument for probabilism but using maximized subjective expected utility. Now, you might immediately think, well, wasn't that exactly what Hedden showed? He showed that there are these non-probabilistic credence functions such that if you accept maximized subjective expected utility, there's no Dutch book, that is, no set of bets that are guaranteed to lose you money, such that maximized subjective expected utility means that those credences are required to accept the bets in that book. That's true, but Dutch books are not the only sort of actions that are exploitable. Accepting Dutch books is not the only sort of actions that are exploitable, and that's because bets are not the only sort of actions that we can undertake. We can also accept, so bets have this very particular structure. For one thing, they have a particular payoff structure, that is, they're, they pay out the stake minus the amount you pay for it, and in one under one circumstance, and then they lose you the amount that you pay for it under the other circumstance. So there's only two options in a bet: the proposition you bet on and not. And there's also and we'll see that so that sort of two things. And then the structure of the payouts is the other thing that's similar about them. So if we expand out, is there some other sorts of actions such that these non-probabilistic credence functions, like the one that we saw Hedden given his example, are there other sorts of actions that those ones require you to accept that are dominated actions? And as we'll see, sort of. What we actually end up justifying here is this thing called bounded probabilism. So let me just say what that is. So bounded probabilism is very, very close to probabilism, but it's differs in its first clause. So where probabilism required you to have maximal credence in the necessarily true proposition, this just demands that you have positive credence. Positive credence in the necessarily true proposition. It then requires you have minimal credence in the necessarily false proposition, and then your credence in a disjunction of mutually exclusive disjuncts is the sum of your credence in those disjuncts. So another way of seeing what bounded probabilism requires is to say that, look, you satisfy bounded probabilism if and only if there is some other credence function which satisfies full probabilism, such that your credence function is a kind of scaled version of that, and that there's some factor, some positive factor, m, below 1, such that your credence function is that fully probabilistic credence function multiplied by that scaling factor. So that's bounded probabilism. It's not full probabilism, but it's what we can get initially, and then we'll begin to ask, can we get a little bit more? Okay, so let's have a look at the pragmatic argument for bounded probabilism. So remember what we have: maximize subjective expected utility. That's our norm that governs what credences is you're rationally required to accept, rationally required to enter into by the credences that you have. Okay. So we can just prove a particular theorem. We're going to go through some. So why we can prove this theorem says, look, if your credences don't satisfy bounded probabilism, and I should say that that example that Hedden has, it violates bounded probabilism. Okay. It's not just that it violated probabilism, it also violates bounded probabilism. If you have you violate bounded probabilism, then your credences are exploitable. That is, there's some series, in fact, it's just going to be a single. It's going to be a single choice. There's a single choice you could face, choice between two different options, and your credences are going to require you to choose, say, the first option, and it will turn out the second option dominates that first option. That is, the second option is guaranteed to be better than that first option. And there's also a converse, but we haven't really been thinking about the converses. Let's see how that works in this particular case. In the case of the case that that Hedden was looking at. So this is the credence function that we described before. Hedden's little example of something that violates probabilism, but there's no Dutch book such that Ramsey's thesis, such that maximized subjective expected utility requires this credence function to accept all of the bets within the Dutch book. Okay, so here I'm now just going to describe two actions, A and B. They're down at the bottom of the screen. I'm going to describe them by giving their payouts in terms of utilities, utiles, their payouts at the three different possible worlds. We're then going to calculate their expected utility, and we're going to see that although one option dominates the other, it's the dominated one that your credences require you to accept. So here's the first action, A. It's going to pay out £78, let's say, or utiles in world 1, 77 in worlds 2, and 77 in world 3. Second option is going to pay out 74 utiles in worlds 1 and 2, and 75 in world 3. So you can see straight away, A dominates B. Guaranteed to be better off by going for A than for B. It will always have a higher utility. But let's calculate the expected utilities. Okay, so we've got option A. Let's look at its expected utility. Well, you're going to look at the credence in world 1, where it has its first, where it takes its first value, and then the credence in the proposition that's true worlds 2 and 3, because that's where it takes its second value, 77. So it's going to be credence in world 1, which is 0.7, times what you get there, 78, plus credence in worlds 2 and 3, the proposition world 2 and 3, times the credence, times what you would get there, 77. Expected utility is 54.6. Okay, let's look at the second one now. This time we look at your credence in the proposition world 1, world 2, the proposition which both of those are true. That's 0.8 times what you would get in those worlds, which is 74, plus your credence in world 3, which is 0, times what you would get there, which is 75. And that just gives you 59.2. So although A is better than B, its expected utility of B exceeds the expected utility of A. Okay, so that's rather peculiar. And it's and because of that, you have a choice such that via maximize subjective expected utility, your credences require you to choose B instead of A, but A dominates B. Okay, so let's just, I think it was quite helpful to prove this. I can understand people might not be particularly interested in the details of this, in which case do skip forward. You're not going to miss anything philosophical, but I thought it might be just interesting to see this. So let's start off. So the thought is you're going to go through each of the different clauses in bounded probabilism, different requirements that it makes, ask what would happen were each of these to be violated. How would you then rig up a choice such that the credences would be required to choose to make the one choice in that over another, but that choice is going to be dominated. Okay, so let's assume first of all we're going to actually start with the second clause. It'd be helpful to start with that. So start with the second clause. Suppose it were the case that you assign a positive probability to the necessarily false proposition. Then maximize subjective expected utility demands that you pay X pounds for a £1 bet on that, if and only if your expected utility for it is greater than 0. Okay, that's your expected utility for it there, because you take the partition with, so that's your expected utility for it there. That's going to be true just in case X lies below, like X is less than, your credence in the necessarily false proposition, which remember is positive by assumption, divided by the sum of your credence in the necessarily false proposition, your credence in the necessarily true proposition. Okay, so just pick some positive number which is less than that, but greater than 0. Then your credences require you to pay that amount for a bet on the necessarily false proposition, but of course that's guaranteed to just lose you that money. There's no way you're ever going to get that pound back from that bet. You're never going to be able to get the pound from that bet because the proposition is necessarily false. So that's the first thing. Now suppose instead that that one isn't violated, so your credence in the necessarily false thing is indeed 0, but the first clause is violated. That is, your credence in the necessarily true proposition is not a positive number, it's right down at 0. So they're equal. then basically it's going to turn out that you're permitted to pay any price whatever for a £1 bet on the necessarily false proposition, because the expected utility of it will be zero regardless, because you're going to be multiple. Your probability is going to be zero, whatever utilities you assign to the situation where the necessarily false proposition is true, and whatever credences you assign to the situation where the necessarily true proposition is true. What utilities you assign to those situations, then the multipliers are going to be your credences in those propositions, but they're both zero, so the expected utility is going to be zero regardless. So, but the problem is that any positive price that you pay for a bet like that is going to lose you money for sure. So if I pay 2 pence to enter into a bet like that, I'm going to lose that 2 pence for sure. So you're going to be exploitable again. Okay. Suppose, okay, so last one. Suppose your credence in the disjunction is not your credence in the sum of your credences in the two disjuncts. I'm just going to assume here that your credence in the disjunction is in fact less than your credence, the sum of your credences in the disjunct. A similar sort of argument is going to work if the inequality is the other way around. Okay, if that's the case, then the following is the case. Okay. So actually, sorry, that contains a mistake. Okay. Okay, sorry, mistake corrected. So suppose that your credence in the disjunction is less than the sum of your credence in the disjunct, then the following is also going to be the case. Your credence in the disjunction plus your credence in the negation of the disjunction is going to be equal to some number x, which is going to be less than some other number y, which is going to be equal to your the sum of your credences in the disjuncts, and together with your credence in the negation of the disjunction. But that's just basically what we've done, just added your credence in the negation of the disjunction just to both sides there. Okay, now what I want to do is just pick 5 different numbers, z1 up to z5. They're going to lie in that order, and they're going to lie strictly between x and y. And then we're going to use those to define two options, two actions that you might choose in a particular decision problem. So here they are. So we're going to, each of the actions is defined on in 3 different situations. Okay, so when x is true, when y is true, and when the negation of their disjunction is true. That covers the whole lot. So A is going to take is going to give you out z5 utiles, so that highest number, z5 utiles, if x is true or if y is true. So if the disjunction is true. It's going to give you z4 if the disjunction is false. So the expected utility of that action is going to be your credence in the disjunction plus your credence in the negation of the disjunction. Sorry, credence in the disjunction multiplied by z5 plus your credence in the negation of the disjunction multiplied by z4. And you can just kind of look through, and that's going to end up being less than x times y. Whereas on the other hand, B, the alternative option, is going to have utility z1 when x is true, z2 when y is true, z3 when the negation of the disjunction is true. That's going to have expected utility. Your credence in x times z1, your credence in y times z2, your credence in the negation of the disjunction times z3. You can figure out that that is greater than xy. So you can see from this that A dominates B, because z5 and z4 are bigger than z1, z2, z3. So A dominates z3, but the expected utility of B is greater than the expected utility of A, because the expected utility of B is greater than xy, whereas the expected utility of A is less than it. So that's going to give you this theorem that our result relies on. So that gives you bounded problems. And if you violate bounded problems, if you've got credences that don't satisfy bounded probabilism, that is, they aren't a scaled down probability function, then there's going to be two options I can describe for you, A and B. A is going to dominate B, but B is going to have higher expected utility than A, so you'll be required by maximized subjective expected utility to choose B instead of A. But of course, that's a dominated option, so by the exploitability conditions, you're going to that you're going to end up being irrational. So by that final assumption, you're going to be irrational. Can we get better than that? Can we get all the way to probabilism? Well, here's a peculiarity of maximized subjective expected utility in the situation where we're thinking about non-probabilistic credences. So suppose you've got two propositions, X and its negation. Suppose both of your credences are positive in positive credence in X, positive credence in its negation. Then according to maximized subjective expected utility, as your credence in one of them rises and the other one stays fixed, then the amount that you will be required to pay for a bet on that proposition your credence is rising in will itself rise. Okay, that's just something that you can calculate. So, and that seems right. Okay, if your credence in the negation stays fixed and your credence in the other thing rises, then how much you'll be prepared to pay for it will rise. In a sense, that's partly what that retains something of Ramsey's thesis. But this is false if one of your credences is 0. So if your credence in not X is 0 and your credence in X is positive, then as your credence in X rises, regardless of what your credence in X is in fact, you're going to be required to pay anything that's less than the full stake for that bet on X. Okay, you can just kind of go through the calculations to see that that's going to be true. And this seems odd. So you might say, well, maximized subjective expected utility does work in the case where credences are non-probabilistic, but with one exception, when you've got a credence in one proposition that's 0 and in its negation is positive, and you're looking at bets on that proposition. In those cases, maximized subjective expected utility doesn't work. Okay, so let's call the resulting sort of disjunctive norm MSEU star. That's the norm that says, in all other cases, use maximized subjective expected utility. In these sorts of cases, use Ramsey's thesis. Suppose you did that, then in fact, you could get probabilism. So if you have that adapted version of maximized subjective expected utility, where you have this exception for cases where your credence in one thing is 0 and your credence in the other thing is in the negation is positive and you're betting on the negation, then you can get full probabilism out of that. It's pretty easy to sort of see how that works, because essentially you just use Ramsey's thesis in these other cases, and that's enough to give you that your credence in a necessarily true proposition should be maximal. If it isn't, and if you're in a situation where your credence in a necessarily true proposition is less than 1 and your credence in the necessarily false proposition is 0, as that clause required of you, then you can just apply Ramsey's thesis to find that's the one that governs in that situation according to this new disjunctive norm. And then you can use that just in the standard way to find the Dutch book. So that's one possibility. So those are our two sort of, in a sense, positive replies to the maximized subjective expected utility objection to the Dutch book argument. They're positive in the sense that they concede that maximized subjective expected utility has plausibility in this area. The first one says, yes, it does have plausibility, but Ramsey's thesis also has plausibility, so let's make both of them permissible to follow, and then you still get problems. Second one says, suppose we just reject Ramsey's thesis almost entirely, or let's suppose we do reject it entirely, then we keep maximized subjective expected utility, and that gets us bounded probabilism. And if we decide we're not going to reject Ramsey's thesis entirely, but only use it for cases in which you have a positive credence in X and 0 credence in the negation of it, and you're thinking about bets on X, then you can get full probabilism as well. The final objection, or the final response to the expected utility objection, takes issue with maximized subjective expected utility itself. It doesn't take issue with it in the case where the credences are probabilistic. Of course, there are people who deny it in that case. So someone like Lara Bushak, for instance, is going to say, doesn't hold in general, even in the case where credences are probabilistic, because it's not required of you to follow, to maximize expected utility. It's required of you to maximize risk-weighted expected utility where you've got some particular risk function. But let's leave those sort of subtleties and sophistications aside. What this points out is that there's a fairly substantial problem with maximized subjective expected utility, even for people who accept it in the probabilistic case, when it's applied in the non-probabilistic case. And the reason is this. A natural thing to think is that norms of rational action should not be sensitive to the cardinal representation of utility. So one way that's often put is that this doesn't really make sense. There's no real sense in saying my utility in this particular outcome is 4. Essentially, any representation of my utility that's obtained from another one by an affine transformation is equally legitimate. So there's no natural 0 point and there's no natural unit for utilities. That's another way of putting it. Rather, any representation that's related to another one by an affine transformation is just as good a representation of that same utility. So that is, suppose it's legitimate to represent me as assigning utility 4 to this particular option A, let's say, in world 1 and 6 in world 2. Then it's just as good to represent me as having utility 2 in world 1 and 4 in world 2, because I've just taken off 2 from both of the original utilities. Or to have utility 2 in world 1 and 3 in world 2, because they're just halved both the utilities. So the thought is that any cardinal representation is only of your utility is only unique up to positive affine transformation. But it turns out and that's fine. Maximized subjective expected utility theory does in fact respect that when your credences are probabilistic. The problem is it doesn't respect it when your credences are not probabilistic. So let's see how that might work. Remember the case that we had before. So this was Hedden's case. It was a non-probabilistic credence function, and there were 2 options that we were using in our pragmatic utility argument for bounded probabilism to show that there was actually, that these credences were actually exploitable, that there was some option that were, some decision between 2 options, A and B, where A dominated B, but where maximized subjective expected utility required you to choose B. And look at, there's the calculation of them down at the bottom. You get signs 78 in world 1, 77, 77 in worlds 2 and 3 for A, and world 1 gets 74 for B, 74 in world 2, and 75 in world 3. And that gives those expected utilities. Now suppose that all we do is take away 77 from each of those utilities. So according to what I just said on the previous slide, that's a perfectly legitimate thing to do, and that's an equally good representation of utility. There's no sense in which that is a poorer representation of utility. Oops, sorry. So that isn't any worse a representation of utility. In fact, it's just equally good. It represents the facts about my utilities exactly as well as the previous representation. But notice, if I take the expected utility of the different options with respect to that, then A does have greater expected utility than B has. So what this shows is that maximized subjective expected utility, the demands it makes, the orders that it puts options in, is sensitive to the cardinal representation of utility. And that shouldn't be the case. You shouldn't have a rational requirement that has that property. You might think, why is that? That's very strange, because in the case of probabilistic credences, then you do get that. It automatically follows that if you represent your utility one way and maximizing subjective expected utility tells you this option is better than that one, then take any affine transformation, a positive affine transformation of it, then the same is going to give the same ordering. Why does it go wrong in this case? Let's just go through this. This is just like going through the maths of it. Well, suppose you have these two options. So let's say, so your PIs are your credences in certain possibilities, and your UIs are the utilities at those different possibilities. And then again, there's some, that's for one action, and then for another action, the QJs are the credences in the different possibilities that are relevant there, and VJs are the utilities for those different options. So suppose that your expected utility for the first option is greater than the second option when your utilities are represented by these cardinal numbers. Now suppose you apply the positive affine transformation in both cases. So instead of ui, we have k times ui plus c, where k is some positive number. And that's a positive affine transformation. Now let's just work through the algebra. Well, it turns out that the result of the applying that in the first case just gives that k times the original expected value plus c times the sum of the probabilities. And for the second one, it's k times the original expected value of the second option plus c times the sum of the possibilities. Now, if those two sums are equal, as they would be, for instance, if your credences were probabilistic, because in both cases those sums those would sum to 1, then you can sort of see that you're going to get those the ordering preserved. Because when you put those on either side of you can sort of see how you've been able to manipulate that first formula, the one up at the top, by multiplying by k, and then on both sides and adding c times 1, just so c on both sides, and then that's going to in fact guarantee that ordering remains the same at the bottom. But if those sums, the sum of PIs and the sum of VJs and QJs is not are not equal, then there's no guarantee that that's going to be the case, and that's in fact what you exploit in the previous case. Okay, so that's the end. So what have we learned? One thing, there's something odd about Ramsey's thesis, and that is that it's at odds with maximized subjective expected utility, which is widely accepted when credences are probabilistic. Does that mean that it should be accepted when credences are not probabilistic? Well, you might think at the very best you get that Ramsey's thesis is correct. Sorry, the permissive version of Ramsey's thesis is correct. That is, you're not mandated to follow it, but it is a permissible way to go about making your decisions. Now, and if you do that, then you're going to get this argument for probabilism. But if you reject it, if you reject Ramsey's thesis in favor of maximized subjective expected utility, then you're going to get bounded probabilism. However, you might be able to get probabilism if you think that Ramsey's thesis is true, but only in very, very, very specific cases, namely a certain sort of specific case that maximized subjective expected utility gets wrong. And if you do that, then you get probabilism. But perhaps the biggest problem here is that maximized subjective expected utility is sensitive to cardinal representations of utility, so it doesn't look like it's actually it doesn't look like it's a rational requirement. So it's a little bit hard to evaluate exactly what's happened with the expected utility argument against objection to the Dutch book argument for probabilism. I certainly think it's not particularly strong, that it's not particularly worrisome for the Dutch book argument, because there are these three different ways to respond to it. The last one is just sort of, if it's correct, it's just sort of devastating to the whole objection. The other two are not devastating to the whole objection, but they do say that actually there's a lot more you can do to reconcile the insights behind the objection with the argument for probabilism. So I'll leave it there. Thank you very much.